Now, let's briefly go over the Squeeze Theorem. The Squeeze Theorem is also called the Sandwich Theorem, and you'll just see why. Now, the theorem says that if you have some function f at x, that's function f at x, and you also have some function h at x. Now, if these two functions, the limit, this point, let's say, is near some arbitrary point b, in x, value b, somewhere near b. So the limit as x approaches b of f at x is equal to, let's say, L. But also the limit as x approaches b of h at x happens to also be L. Now, if you have these two functions whereby the limit of those functions near this point b are both L, and you somehow have a function between them, let's say that function is f at x. Now, if these two functions are both L at here, and this g function tries to squeeze itself, tries to like squeeze, this function is less than f at x, but it's greater than h at x. So it is between them, they sandwich it, and it tries to squeeze in here. It will also be forced that the limit as x approaches b of that function in between those two functions will also be L, because it can't be greater than L, because this function is not greater than f at x. Also, it's not less than h at x, and they are both equal to L. So if it has to squeeze in between these two functions, it will also come out as L. Now, let's write that in mathematical terms. We say that if you have a function h at x, and you have g at x between h at x and f at x for x near b. Now it's near this point, it's approaching this point but never reaches that point. And also if the limit as x approaches b of f at x is equal to L, which is also equal to the limit as x approaches b of h equal to x. It therefore forces the limit of g at x as x approaches b to be equal to that L also. It squeezes this function, they both squeeze this function so that it is equal to their limit, and therefore that's why we call it a sandwich theorem. Let's take a couple of examples. Let's say that you have a function f at x that is between x squared and 5x plus 2, and you want to find the limit as x approaches some point, let's say and you want to find the limit of this function as x approaches a point, let's say number 3, x equal to 3. Now, you will want to find the limit of every function. Now, the limit as x approaches 3 of 5x plus 2, also the limit as x approaches 3 of f at x. This is what we want to find, the limit of f at x as x approaches 3. Also, we'll take the limit as x approaches 3 of x squared plus 8. Now, the limit as x approaches 3 will basically substitute this 3 into this x, which will be 5 into 3 plus 2, which gives us, that's 15, 17. We're still looking for the limit of f at x as x approaches 3. And we also substitute 3 in here. Now, 3 squared will be 9, and 9 plus 8 will be 17. Now, if this limit and this limit are both equal to 17, and this function is in between them, it is sandwiched by these two functions, that will therefore conclude that the limit of f at x as x approaches 3 will also be 17. Because it can't be greater than 17 because this function is not greater than this function. So it cannot be greater than 17. And it cannot be less than 17 because it's not less than this function. So it cannot be 16, 17 because it's not less than function. So it will be squeezed into 17 or sandwiched into 17. Let's take the last example. Let's say you are looking for the limit. What is the limit as x approaches 0 of x sine x?